Welcome back to this series of circuit analysis using nodal techniques. So we are solving the circuits with the supernodes. So this is our next example. In this example, the question is find the value of I naught. Okay, so if you look at the circuit, I naught is the current that is flowing through this resistor 2 kilo ohm. Okay, so we can write that the value of basically I naught will be what? Like the voltage here, the current through a resistor, okay, difference of nodal voltages, right? So V3 minus, what is the voltage here? 0 divided by 2k, right? Or simply V3 over 2k. So if we can find the value of V3, we can find basically the I naught current, which is our desired uh, question requirement. Now, to get that, we are going to use a nodal analysis. Nodal analysis is to get the nodal voltages for all the nodes. So we have 4 nodes, okay, except the reference node here. So like we have V2, V3, V4 and V1, okay. So first off, we will try to see like if we can get some nodal voltages values directly. Why? Because we have independent voltage sources here. So if we found a voltage source that is connected between a node and a ground, okay, like here, so we can get its value directly, like V2 minus 0, that is basically what? Minus 6, okay. So V2 will become minus 6 volt. So we can get a value directly. Second, we can find here, like there is another source which is connected between a node and a ground. So V4 minus 0 is equal to 12 volts. So we got our second one also. Okay, so we can get node values directly. Third, we are left with V1 and V2. So if you look at V1 and V3, so if you look at V1 and V3, what we can notice? That we have a voltage source that is connected between the two nodes. So we have learned in the previous video examples that if we found a voltage source that is connected between two nodes, that will be called as what? That will be called as a supernode. Okay, so we have over this yellow highlighted supernode here. So now we will write the nodal equation for this supernode. How we can write? We assume that all currents are leaving from the supernode. Okay, so like with reference to V1, the current leaving through 2k will be this one, current leaving through this 2k will be this one. Let's write it down. So what is this current? So V1 minus this node, right? V1 minus V2. What is V2? Minus 6, right? Divided by 2k. Current through this 2 kilo ohm. What will be that? This voltage V1 minus this node voltage. What is this node voltage? 12 volt, right? Divided by 2k, right? Then we comes here V3. So with reference to V3, current through 1 kilo ohm. What will be that? V3 minus V2, right? V3 minus V2. What is V2? Minus 6 divided by 1k. Then current through this 2 kilo ohm. What will be that? V3 minus 0 divided by 2k. The last one, the current through 1 kilo ohm. What will be that? V3 minus V4. What is V4? 12 volt divided by 1k is equal to 0. Okay, so this is our equation. Okay, with that we will also write the equation for our actual supernode. What will be that? V1 minus V3 is equal to 12 volt. This is our actual equation of our supernode. So let's simplify this one. So we can simplify this whole by just multiplying with 2k. Why? Because this is the lowest common multiplier of all denominators. So let's see what we will get. This 2k will be cancelled. So I have V1 plus 6. Then this 2k again cancelled. So I have V1 minus 12. Then 2 divided by 1k, k will be cancelled. So we got 2. So 2 times of V3. So minus plus 6, right? So 6 times 2, 12. Okay, so we have 6 times 2, 12. Then again 2k will be cancelled. So I have V3. And the last one, k will be cancelled. So I get 2. So 2 times of V3 and minus 12 here, it will become minus 24. This whole thing is equal to 0, right? Let's just rearrange it. So we have V1 here. Okay, we have V1 here. So that will become basically 2 times of V1. Then I have V3 here, I have V3 here, and I have V3 here. So what will I get here? I get with 4 times of V3, right? 2 plus 3, 3V3, and then I have 2 times. So that will be basically 5. 5 times of V3, right? All right, so then we are left with the constants. Okay, so this minus 12 and this plus 12, that will be cancelled out. So what we have left? We have plus 6 and minus 24. So what is plus 6 and minus 24? That will give me minus 18, right? So minus 18 goes to the other side, it will become 18. So we have our this equation here, right? Now we have two equations and two unknowns. One is this one and the other one is this one. So let's substitute v1. We can substitute as v1 will be v12 plus v3. So let's put that here, like in our equation 2, like this is equation 1 and this is our equation 2. All right, so 2 times of v1. What is v1? 12 plus v3 plus 5 times of v3 is equal to 18. So what we have here? 12 times 2, 24, plus 2 times of v3 plus 5 times of v3 is equal to 18. Okay, so 5 plus 3, what will be that? 5 plus 2, sorry, 7 v3. So 18 minus 24, that will be minus 6. So what is the value of v3? Minus 6 over 7 volt. So we have v3. Also, we don't need v1. Why we don't need v1? Because we have just want to find the I naught, which is v3 over 2k. But just for the case of calculation, v1 basically will be what? 12 minus 6 over 7, right? 12 minus 6 over 7. So what will be that? 72 minus 6, 66 over 7 volt. Okay. So our target of this question was to get the value of I naught. Okay. So we know V3. What will be the value of I naught? So I naught will be V3, which is minus 6 over 7 divided by 2k. Okay. So what will be our answer, students? Okay. So this 2 and this will be cancelled. So we have minus 3 over 7 milliampere. Okay. So this is our I naught of this circuit. Thank you so much.